Okay, so the lesson this week is over comparing functions. A lot of it is being able to identify what the slope is or the rate of change, and where the y-intercept is or the initial value. So first we're going to start with identifying those pieces on slope-intercept form. Remember that slope is the change in y values over the change in x values. In other words, rise over run, or the change in y over the change in x. The y-intercept, we can call it the initial value. In other words, it's where it crosses the y-axis. All right, so in this diagram, what does m represent? What always goes with the x value? Slope. What is the b value? Y-intercept. Okay? In our equations, you have to be able to identify slope and intercept. That's why we have a slope-intercept form. What is the slope in the first equation? What is the y-intercept? And in our second equation, go ahead and write them down. What is the slope? Negative 2/3. What is the y-intercept? Is it positive 5 or negative 5? How do I know it's negative 5? Yeah, you're going to have to make sure that you look at the sign that's before the value. Okay, now let's look at a graph. Usually the intercept is the easiest thing to find on a graph. The y-intercept is where it crosses the y-axis. In this case, what is the y-intercept? Let's assume that its units are counting by 1. So what is that y-intercept? 3. Okay? And now we need to find the slope. First, look at the line, and is it a positive or a negative value? It's going to be negative because it's decreasing from left to right. You're going to need to find 2 whole number points. We can use our intercept, and if you follow this line down, it crosses the grid right here again at 1, negative 2. You could find it by counting rise over run, or you could calculate it by doing y2 minus y1 over x2 minus x1. Given a graph that's as clear as this one, I would count rise over run. So for our rise value, that's the vertical. So this is 1, 2, 3, 4, 5. How far over? 1. And what is negative 5 over 1? Negative 5. Now, if you were to do it the other way, you have the intercept at 0, 3, and then this other point was at 1, negative 2. You could take y2 minus y1 over x2 minus x1 and find the exact same values. Negative 2 minus 3 is negative 5. 1 minus 0 is 1, and that gives you negative 5 over 1. Okay, on the next graph, what is your intercept? Negative 4. All right, and now we need to find our slope. The intercept is a good point to start with. You're finding your slope, and then follow the line up to another whole number value. What ordered pair is that next whole number value at? Okay, it's at 1, 3. Okay, so now count the rise. How far up is that? Seven. How far over is it? Okay, and is this a positive or a negative slope? It is a positive slope. What is 7 over 1? Just 7. Okay, let's look at it on a table. Who remembers how to find the y-intercept on a table? Miles? The y-intercept is found where x is equal to 0. So what is the y-intercept in this case? 12. All right, now we need to find the slope. Remember, the slope is the change in y over the change in x. So we have to figure out how are the y values changing? Add 6. How are the x values changing? Add 2. So what is 6 over 2? So the slope is 3. Okay, go ahead and look at the next table. Is there a 0 value in the x's for the next table? No. So how are we going to find the y-intercept? Miles said just work backwards. What is this increasing by? Or decreasing by? So it's decreasing by 4 each time. So Miles said we'll work backwards. Instead of subtracting 4, add 4 to find the number before it. What was the number before 37? Okay, and so what is the number before 1? What are the x values changing by? 1. So what is negative 4 over 1? Negative 4. And what is the y-intercept? 41. So that's how you would approach a table that does not have the 0 value visible. You would work backwards. So make yourself a note that you need to work backwards. It's not always evident to us that we need to do that, but sometimes we have to.